So that's pretty neat. Now I have that pod running. If I say get pods, it's going to list me the pods. Now I'm going to show you the cool part, in my opinion, of Kubernetes is that I can delete that pod. I'm just going to say delete pod. Okay, I deleted it. And imagine deleting your application instance. Like if you had your application running on an EC2 instance or a Google instance, I've just deleted my instance. That's a big deal, right? Well, not in this case. If I say get pods, what you're going to see is there's already another new pod running. It's only been 15 seconds. I didn't even have to barely wait. And it has a new ID, which means it's a new container. So this is kind of where the self-healing stuff comes in, is that if I have a bunch of these pods running, and one of them dies for out of memory or fails a health check or whatever, it doesn't matter. It's going to be removed from the service. Something else is going to come back. So it really kind of takes the headache away of having to worry about instance management. So we've got our master pod, which is fine. We only have one of them running, which is also fine. And now I'm going to kubectl apply the minion. Same thing. Deployment's created. I'm going to skip the whole describe thing, and I'm just going to say get pods. So it's creating those containers. Now, based on how big your image is, because it has to pull it, and how long it takes your application to set up, that container could be potentially creating for a little while, right? We have some customers whose app takes 45 seconds to start, which isn't great, but it's not terrible. It's way faster than starting up an instance. And now if I say get it again, they're all running. So that's pretty cool. And so now I have pods running, but I have not exposed them, which means I can't necessarily point any apps or people to them, right? And so they're essentially running but non-functional right now. And as I talked about earlier, the way that you expose something is through a service. So let's take a look at the services. Again, I'm going to kind of just show you what the YAML resource looks like. In this case, super simple. Kind service, got some metadata, and then ports is important. So remember on the deployment, we exposed a certain port. In this case, we're just telling the service, this is the port that you're going to be serving. And then the selector is important. The selector is going to tell the service which pods are going to back it. So if you have certain labels that you've given your deployment, this is where you want to put them. Okay. Yep.
Are all these labels, are they convention or is it
so his question was, are these labels convention or do they mean something? So these are completely made up. These are something that my colleague decided was important. We have conventions that we use with our customers that make it a little bit easier for us to understand what's running where, but it's completely up to you. I see a lot of people just use name. OK, so that was what a service looked like. Let's go back and deploy a service. So I'm in the same folder. I have my service files, and I can say kubectl apply -f, same deal, Redis master service. I need a master service so that my web app can talk to Redis. OK, that's what that's for. And I need a service so that the master can talk to the minions. So that's what my that second service is for. So Redis slave service. OK, so now I have two services. If I follow the same conventions that we've been following before, I can say kubectl get service. Get service. Yeah, sure. OK, so now we have two services. Pretty cool. So you'll see that there's a couple fields here that are interesting. Cluster IP. What the heck is a cluster IP? So Kubernetes does a bunch of internal networking so that containers on different nodes can talk to each other. And so that communication within the cluster is a thing. So it will have a completely different network CIDR than your external network probably. So don't panic about that. But it's going to use that for internal addressing. Now, you'll notice that external IP says none. So you're probably thinking to yourselves, how is anybody going to hit that? Well, this particular service, if we go back to the Git repository, does not have a type defined. There are 3 different types of services in Kubernetes. One is node port. Node port exposes your application on a assigned port, like high port value, the same port on every node, so that within the cluster, it knows that that application is running on that node port, that port. And so this node port service is really useful for internal communications. So if you have applications that need to talk to each other, you want to use the node port, because then all the traffic will stay in the cluster, it'll stay fast, it'll stay local, and it doesn't have to go out into the internet and then come back. So if you don't define any type, I think the default is node port, which is what we wanted anyway. The second type is load balancer. Type load balancer will, in whatever cloud service you're using, create a load balancer. So in GKE, it creates a cloud load balancer. In AWS, it creates an ELB. And it does all that magically for you, which is so awesome. It will create that cloud resource. It will control that cloud resource. It will create security groups for that cloud resource if you need it. And if you ever delete it, it will clean that all up for you, which is rad. I love that. And so we'll get to that in a minute, because our web app is going to need one, right? So in this case, we're using node port. The third is cluster IP, which I have yet to use with a customer. I'm not even that clear on what IP they're giving it, but I'm assuming what's happening is that with the service, you're giving it essentially a static IP, which actually, I take that back. We have had a customer use it, and it was for SFTP, which please don't run SFTP in your Kubernetes clusters. OK, so we have our node ports. That means that those 2 things can talk together. And potentially, when we deploy our web app, it can then talk to the master. What I really want to show you, which is, this is super coolness. We're going to see if it works. I am going to show you, let's do get pods. I'm going to show you how to exec into a container. So let's say kubectl exec. This is almost like running a Docker container, getting into a Docker container in the Docker daemon. So you're going to say exec. You're going to say interactive. Give me a TTY. I'm going to put the pod name. Let's go into one of these minions. And then you do a double dash. And then everything after the double dash is a command you want to run. So I'm just going to do bin bash and hope for the best. Yeah. So it dropped me into a shell. I'm in the container now. So now I have essentially SSH access into my pod, right? This is what a developer would use to get into their pod, to see what's wrong, to mess around. And I didn't even have to have any SSH keys, which is awesome. So here I am in my Redis. And what I want to do is show you that node port can essentially give us internal communication. So if I say env, it's going to show me my environment. You're going to see that Kubernetes added a couple environment variables for me. And they are based on the services that I have running. So I have a Kubernetes service host here. I have, do I have Redis? I'm not getting what I want, but let's try dig Redis master. Oh, dig's not found. Look up. Ping. I may not have the tools that I need to show you this. OK. So I'm not allowed to talk to the master because I'm a minion. However, this is what I wanted to show you here, this line, if everybody can see it. What it did was take that name, just Redis master, with no domain name or anything like that, and it translated it into internal cluster DNS. So if I configure this properly, what that gets me is that all I need to talk to other pods in the same namespace is just the name of the service, which is so awesome, because now I can configure my web app to just talk to API. I don't have to say api.customer.com. I can just talk internally, which is super cool. And I didn't prepare this, so that's why I can't really show you the reality of it, but I'm just planting that nugget. Okay, so I know I only have a little bit of time left, so I want to not talk too much. So now I have my Redis deployments running, and I have my Redis services, and now we're ready for the web app. So let's go back up a directory and go into the web app. We have a deploys folder. Okay, so now here's my web app. We have a deployment, a horizontal pod autoscaler, which I'm going to explain, and then a service. So let's do exactly what we did for Redis. Let's apply those. I'm ready for it. Put out my deployment. You can get pods to make sure that's good. Container creating. Still creating. I do this a lot. You could also do -- watch, which is neat, because it will just keep watching for you, and it'll update you hypothetically when it finishes. Why are you taking so long? Oh, let's do something else. This is also what I do all day long. Let's do something else while we wait. So let's apply that service just because we know we're going to need it anyway. Where are we? It's called app. Apply -f app.service.yaml. Now, if we go to the actual app service, web app, we're going to see this little jammer here. Type load balancer. Yes, exciting, cool. This means it's going to be public. If you are in GKE, it's going to make you a public load balancer. AWS will allow you to have an internal or a public. Maybe GKE does it internal as well sometimes. I'm not too familiar with that. But you can essentially, by annotations, which are like more metadata, you can control the properties of your load balancer. So say you needed to attach an SSL certificate, all you would have to do is add a little bit of metadata to then attach that SSL certificate to your load balancer. And you can do that all through this YAML. You can have Kubernetes just handle it for you, which is awesome. Okay, back to the console. If we do get services, type properly. Okay, awesome. We have a web app service. It has an external IP. That means we can access it. Awesome. Okay, so let's get that. I'm going to open a new browser. I'm going to hit it. Hey. So we have our app, and it's serving, and that's really cool, and it's public and everything. If you look on the repo that Eric wrote, there's a little bit of a README. It tells you what you can do with the app. You can, that's what we did. We hit port 80, and it just said hello. If I am to run /app, it's supposed to say look, no hands. And then this set and get are essentially accessing Redis. So let's make sure that that works. Let's say set foo bar. Okay, so trying to add foo with the value bar, adding foo with the value bar. Now the real test is whether or not foo actually got set to bar. So we can do that. Hey, excellent, it's functional. That means all of our pieces are talking, which is great and cool, right? Awesome. So let me show you, if you are a developer, there's a cool little, so I showed you how to exec into a pod. That's super useful if you're a developer or an ops person. There's a second thing that I think is super useful, which is tailing the logs, right? So if you do kubectl logs -f, it's going to tail logs for you. I just need to give it a pod name. So let's do, I don't know, yeah. Let's grab my web app pod, and we'll do that. And it's tailing the logs. Now, logs -f will show you the entire log history and then start tailing the log. So it's kind of useful because, you know, a lot of the time, whatever you want to look at has happened already. The way that Kubernetes logs to Stackdriver? I'm sorry, my brain is not working. Stackdriver is that all the containers should be set to log to standard out, and then it will pick up those logs and send them off to Stackdriver. So sometimes logging into your pod or execing into your pod and trying to find a log file is not going to work for you because you should be logging to standard out. And, oh, thank you, somebody's hitting my app. And so then, so that's, you want to tail the logs. There are cool third-party packages, open source packages, that will allow you to do cool things like tail multiple pods at once. And it'll even pick up new pods as they come up, which is really cool and useful for troubleshooting. The two that I use are kubetail and Kail, K-A-I-L. So check those out if you're interested. Thank you for adding load. This is great. If everybody could just hit it at once, then we could scale it. So I'm going to cancel that because that's, but now I'm going to show you the horizontal pod autoscaling. So we talked about cluster autoscaling, right, where you add new nodes to your resource bucket. The second type of autoscaling is horizontal pod autoscaling. Remember when we wrote our deployment and it said replicas 1? That's obviously not a good thing if you want to parallelize your workflow. So you could do replicas 5. You could do replicas 10. We have customers who do replicas 200. And that just handles all of the workflow, right? If you set Gunicorn or Puma or whatever it is to be single-threaded, you could potentially have one container for each person that's hitting your website, right? You could do that if you want. There's a lot of scheduling overhead. But the idea is that you could potentially have as many containers as people hitting your website, right? And so in that case, you're going to have to scale. You have to scale with customers. So sometimes Black Friday, you're going to have 1 million containers, and sometimes you're going to have 1. And so let me show you how to do that. So we go back to the repo under web app deploy. There's this horizontal pod autoscaler. It looks familiar by now, hopefully, and it's just a YAML resource, and the only things that are really important with HPAs are the min and max. It's like an autoscaling group. You tell it, this is the minimum number of replicas that's okay, this is the number of max replicas that's okay, and this is how you scale it. So hopefully everybody can read that, but it is target CPU utilization percentage. So it says 30 right now. That means if a pod goes over 30% CPU usage, spin up a new pod. Cool. You can actually do a lot with this. You can have it, there's a thing called custom metrics, which you can enable, which will allow you to scale on cool things like queue depth. And so this is really powerful if you want it to be. We find that a lot of workers are fine, they're CPU bound, so we just trigger it on really low CPU usage and then it'll scale up. So I have my HPA. Whoops. Oh, it does, yes, I'm sorry. If the CPU usage then goes down, it will scale down. So it's a really good way to have cost savings, right? Because if you have HPAs and cluster auto-scaling, then if your workflow and your HPA shrinks and your cluster can shrink, now you're saving money, right? Cool. And especially since Google has billing per second, you can save a ton of money. Awesome. Okay, so we are in the deploy folder, and we can kubectl apply -f, just like we do everything else, the horizontal pod autoscaler. So now if I take a look at that, I can say get HPA. It's going to show it to me. It shows me that I have a min of 1, a max of 50, and right now it says unknown, which is fine because Heapster, which is what I mentioned before, that monitors the resources of each pod, has to be running for at least a minute before it gets any resource usage. So potentially this could take up to a minute to register anything, which is only true the first time. Okay, so here we go. So now we can see 1% CPU usage. Maybe if some of you hit it some more, we'll get some more, but probably not. But the idea is that the target, if it goes over 30%, will then scale. I've done a couple A/B scripts that will sort of do this, but I probably break the Wi-Fi. So I don't know that we're going to get to automated scaling today. This is kind of what I hinted at with the advanced people to write a script for it. If you want to hit my site with it now, now's the time. No? No? Okay. That's fine. So one of the things that you can do is scale manually, right? So say that you know Black Friday is coming, you know that you're expecting a huge load, you could potentially scale your HPA ahead of time. There's a couple ways you can do that. You could edit the HPA. Edit is kind of a cool thing for anybody who's a Vim user. You can edit everything without having to reapply it. You can just say edit HPA. It's going to drop you into an editor, and then you could change anything that you wanted, and as soon as you save and quit, it will update that. So what if I do change the min, I save it, now if I get the HPA, I should say 10. Oh, yay! Thank you. You guys are awesome. So now it's at 56%, and so we could potentially see it scale, which, again, here I am. Can we watch it? Oh. HPAs do have a response time, and I think, don't quote me on this, that you can customize how fast it scales up and how fast it scales down. I can't say that I've done that myself, but it would make sense, right? You could potentially scale up really fast and then scale down a little bit slower, which makes sense because you want to make sure that you're not, oh, hey, look at this. Okay, so we got 10 pods, 10 replicas, and if the load continues, we should have more. I'm just going to leave this up. I think that's all I really want to say about HPAs. Does anybody have any questions?
Yeah, so like in this case, you have a Redis instance, right? And it's shared across like each. What's the word I'm looking for here? Each replica, correct?
Redis instance.
Like, sorry, is the Redis storage shared across all of them?
Yes. So he asked if the Redis storage is shared across all of them. It is.
Okay, and how? Like that's the part I'm a little like.
How is it shared?
Yeah, because I understand like if it's in one area you have a master and then 2 slaves or whatever, but then you're launching these new containers.
Okay, so right, my web app deployment has a bunch of pods in it, right? And they are using the Redis master service. Okay, the Redis master service is a DNS name that it hits. The Redis master service has all of the Redis master potentially pods behind it. Currently, there's one Redis master pod, and they're all using it because that's the only pod sitting behind that service. Okay, if I were to scale the Redis master HPA, like if I added an HPA for it, then I would have multiple, and it would then load balance to all of them. Currently, the way that it's set up is it's hitting the one master, and then there's multiple slaves behind that. And so you could potentially just scale the minions underneath, but eventually you probably would run out of master bandwidth, right? And then you would want to scale that as well.
Do you have any experience on like primary relational storage databases and stuff, like how people usually set up? I mean, obviously it varies from.
Don't put a database in Kubernetes.
Okay.
He asked if you have experience with running a database in Kubernetes. Please don't do it. It'll work, and people have some success. The thing is that there's something very non sequitur about running persistent state in an ephemeral environment. So Kubernetes is a thing called persistent volumes. It's just like Docker volumes. You mount a storage to a pod, and that pod uses it. Actually, in GKE, in Google, this works really well. We have a customer who mounts volumes to pods that are specific to a user who logs in. And when that user logs out, the volume is detached. The user logs back in, the volume is reattached. It works great. It does not work great on every other cloud platform. And if you lose your volume or your volume becomes in a bad state, so like maybe it's detached, but Kubernetes doesn't think it's detached, then you can really get into a bad situation where the only option is to delete your data and start over again. We don't do that with any of our customers. We recommend that you use a data service to house your data. Kubernetes has this abstraction of an endpoint. An endpoint can be outside your cluster. It's just kind of a friendly name for your cluster to use it. So you could potentially create an endpoint in Kubernetes that points at your Cloud SQL if you wanted to. Okay, so thank you to all the load people. it looks like we're actually scaling. Awesome, right? We need to scale a lot more. But we've got up to 19 replicas, and that took a little while. So it looks like the default on the HPA takes a little while to warm up. So just like you would with a load balancer, you probably want to warm up your HPAs. But you have basically shown for me what it will do. And in this case, what I would probably do if there's this much pressure on it, I would probably help it out a little bit by adding, like raising them in so that it could go a little bit faster. Really, what you're limited by is how fast your app will spin up. So if you have an app like this one, which starts up in a couple seconds, it's not so bad to just HPA all day. If you have an app that is heavy and takes maybe 45 seconds to start, you're really going to want to make sure that you have enough replicas to start with, to be honest. So there's that. OK, so that is the end of the demo. And I'm almost at 5, so I didn't do too badly. So I guess now I'll open up to questions and hit me with what you've got. We have a couple mics around here if you'd like to go up to them, or I'll repeat your question for you.
All right, so when you were doing exec on a pod, I thought like in the beginning you said that a pod can be one or more containers.
Yep.
So how do I know which container I'm actually execing on?
It's a great question. Right, so because so his question was that when I showed how to exec into a pod, it just went into the one container. But if I have multiple containers in a pod, how do I tell it which container that I want to hit? So it's a great question. If I were to have a pod with multiple containers in it, what it's going to do is going to say, I don't know which pod you want. And it will prompt you with the names of the pods or the names of the containers that are in that pod. And you can then specify which container you want to get into by doing a -c flag to then specify the container name. It will, by default, just enter a container if it's the only one. Yep.
I wonder if that should be more of a database. You have namespacing per user, for example, that have completely separate services. Often we need some data and we need data per user.
Mm-hmm. Yes, so that's actually a very good use case for it. So his question was essentially, if I understand it correctly, if you have a different user, a different developer for each namespace, and they need their own data, is it OK to run data in the cluster? And that is yes. We have a customer who has a very large dev team, and they have, like I said, a namespace for each feature branch, and that's super important to have a service for each namespace or each app in a namespace so that they can do a bunch of work. And we actually added a Redis container or a Redis pod to each namespace for them, and we'll probably do a Mongo for them as well in the future so that their developers can then have their own data set. And it becomes much easier to do things like that if the developer, the app team, has things that will load data into those containers or mount into those containers. But that's a perfectly acceptable use case. Mostly when I say don't use databases is this production. It's just there's so much that could go wrong. In the back?
For the slave to use the environment variable get hosts from DNS, is that something that was special to the container that you did, or is that
That was special to the container. So his question was the environment variable that I set in the Redis deployment. If I track back to it, I believe it was this one. No, this. OK, so this environment variable, he's saying, is this value specific to the container? And the answer is yes. So this Redis slave image is essentially written to accept the get hosts from environment variable. And so I'm just setting the value that that container expects right now.
How does that container load those? How does it fetch all the host names?
So I'm not clear on, I've never touched this Redis slave image, but what I'm assuming is that it knows that it can look in the internal cluster DNS for any Redis minions that have been published, and then it will configure. To be honest, I don't know the specifics, but I'm assuming that it is using internal cluster DNS.
Hi.
Hi.
Yeah, is this working? Yeah. I was going to ask if for load balancers, if you're running on premises, uh, how does the IP get exposed? Like, I can understand in Google Cloud, like it's probably setting an actual load balancer with an IP and exposing that, but how does it work on premises?
Right. I think for on-premises, what you would probably need to do is use the cluster IP type of service, which will set essentially a static IP that will front your service. So then from external, whatever DNS that you have set up in your data center or whatever will know that that IP is, your app, and then that cluster IP service will then have all of your pods behind it. Does that make sense? Yeah. I work mainly in cloud, and I don't think we have any on-prem customers, so we don't use that cluster IP, but that would be a good use case for it, I believe. Any more?
Yep. You talked about that file system getting mounted from Kubernetes, right? Can you tell us something more about it? Like, can I use it for persistent storage for like a service, like a message queuing service or something like that?
So his question is around persistent volumes and whether or not you can leverage that for messaging. Absolutely. You can use the persistent volumes for whatever you'd like. Persistent volumes in Kubernetes have a lot of complexity, but a lot of flexibility. So there are static persistent volume definitions, and there are dynamic ones. If you're in a cloud service and you use a dynamic persistent volumes, it can create storage on the fly for you, and it will connect them to pods based on your needs. Or if you're using it for message queuing, you could potentially create a cloud storage volume or EBS volume with some other type of automation or manually, and then you can specify exactly what that persistent volume is to Kubernetes, and then you can say there's something called a persistent volume claim, which will essentially define what containers can use that persistent volume. And so you could use it till your heart's content.
And does that persistent volume get replicated across zones, availability zones? Like, is there some...
Great question. Does the persistent volume get replicated across zones? No. Not by default. You can probably make it do that. But as far as I know, in most cloud providers, volumes are specific to availability zone, and so you need to make sure that you replicate them across yourself. Yep.
I know you skipped over RBAC a little bit.
Yes, I did.
Go back to the secret stuff a little bit. Is
Sure.
there a way, and it might not be out of the box, or maybe in your experience with ReactiveOps, dealing with some sort of, I guess, RBAC interaction with like secrets? Like, because we're thinking about how we might be setting up multiple environments, Kubernetes environments for multiple customers, where obviously their secrets are going to be like very different, and some sort of, and even from our own dev engineering team, with like some sort of,
Access around secrets.
Exactly.
Okay. Yeah, his question is based around RBAC, the role-based access controls that I mentioned briefly, and whether or not it can control access around things like Kubernetes secrets. And the answer, as far as I understand it, is yes. If it is a resource in Kubernetes, you can control access around it. And so potentially, based on the roles that you assign to your secrets, you would be controlling access of services or users. So if potentially you had a secret that was only specific to development, then you could define the metadata, the users, the services that are allowed to touch that data. And you could do that with some sort of metadata or service accounts. Does that make sense?
Okay, and I guess, so for the actual like DevOps or developers and stuff, it would work across them too? Like,
I believe so, yes. So we don't do this with a lot of our customers yet because it's newish, but there are definitely ways that you can, and actually GKE does it out of the box, is that it gives certain users access to certain things. And so, yes, you can block all of your developers from seeing the secrets. And I recommend that you do that. There's no reason, unless it's really a scratch environment, that you want that to happen. And this is actually a really interesting problem because, we have this whole world of PCI compliance and HIPAA compliance and things like that. And part of those is nobody's allowed to see my data, not even my ops people. And so how do you control the access to your secrets from your admins, right? That's really hard. And so I think that that's one of the problems that RBAC can help with, is if you define the roles very specifically, then you can stop people from seeing secrets or seeing configs or seeing even containers that are, or pods that are running. Yeah. Oh, sorry. Nope.
So very early, you had gone into the area where you had like multiple contexts in your
Yes.
one cluster.
Yes.
When dealing with a situation where you have to like have a production environment, a testing environment, and multiple testing environments, what is the correct vocabulary for the like each environment? Is each environment a separate cluster, or is it each environment a separate context?
So Kubernetes does not necessarily have the concept of an environment. So you have to map an environment. I'm sorry, his question was whether or not, we talked about context earlier, and he was asking how we map an environment to a context. So Kubernetes does not have the concept of an environment necessarily as you would think of it. You kind of have to create that for yourself. The common way that we do it is by creating a namespace per environment. So we have a staging namespace, a development namespace, a production namespace. Well, yes and no. You could potentially put them all in the same cluster, right? But we recommend that you have, we call everything below production working. So we usually have a working cluster and a production cluster. Production is its own thing. It could even be in GKE its own project so that it's completely segregated from everything else. And then your working cluster could potentially have any number of environments, right? We have some customers who have development 1, development 2, development 3. We have some customers who have feature blah, feature foo. We have some customers who do one namespace per developer. But the most simple, direct, recommended way is a namespace per environment, and just have your CI deploy to that namespace based on what branch you're deploying. So we see a lot of the time anything with the prefix feature will get deployed to development. Anything with that's merged to master will go to staging, and anything that's tagged as a release will go to production. That's the most common. Yep, sure.
Off topic, but I know that there's a dashboard in Kubernetes.
Oh, yes. Yeah. Sorry, I forgot to show you the dashboard. The reason I forgot is because you can't really, oh look, it scaled back down. You can't really do it in Cloud Console. So his question was based around seeing the GUI. There's a couple ways you can do that. You can hit your API DNS. So if you mapped your cluster API to a particular DNS name, you can hit that DNS name. You can say /UI, and it will give you a HTTP basic authorization box pop up, and you can put in the admin password if you wanted to. I can go ahead and show you that. The other way that's recommended, that's most common, is by using kubectl proxy, which will allow you to authenticate yourself into the kube GUI using your kube config. So I'm going to move to my external terminal, which is going to require me to set my project properly. So I'm going to scroll through my history here. This guy. Okay. So now hypothetically, I should have my kube config. Looks like it. Okay. So now I should be able to, oh, that's not going to work. kubectl get nodes. I just always do get nodes as a test. Okay. We're in the right place. So now all I should have to do to get to the GUI is kubectl proxy. It's going to tell me it's starting to serve on localhost port 8001. And so if I go back to my browser, I can say, so it was localhost 8001/UI. If you don't do the /UI, it's okay. It's just going to tell you all of the API options available to you. And you could use that to hit the API. But if you do UI, it's going to take you to the dashboard. One thing that sometimes confuses users is that this dashboard's not always installed. GKE installs it by default, which is awesome. if it's running as a pod, like everything else. So if you were to actually, if I can find my console again. If you were to actually look in the kube system namespace, if I get pods there, you're going to see basically all of the kube internals, but you'll see here, Kubernetes dashboard is running as a pod. Cool. So you could deploy that like anything else. If you don't have it on your cluster, you can Google it, dashboard, if I can type properly. And what you're going to find is that they're going to provide you with, this is a really old version, but there is a newer version that essentially, like, you look at it, it looks just like all the files we've been playing with, right? And so you could take it and you could kubectl apply it. So there's that. If we look in the dashboard, it's actually really nice. And the newer versions are even nicer. You can explore everything in your cluster without knowing that it exists. If we, I canceled the kubectl proxy. The only advice that I'll give you on this kubectl proxy is that if you're running multiple clusters at once and you're going to kubectl proxy to them, you're going to have to make sure you keep track of which cluster you're in, because it's going to default to 8001, and so you could potentially be hitting one cluster and expecting the other. You can customize the port with a P flag. Okay, so we're back in the dashboard. Look, my workshop namespace is there. If I click on it, I can see all of the events that happened during this workshop, and you can page through it if you'd like. I can look at the nodes that I've got. I can look at the CPU and RAM usage of my nodes as a whole. You can see that when we scaled, we went way up, which is cool. If I were to click on a specific node, I would see the usage of that node. I can also see all that information that we got from the kubectl describe node. And then down here, I can see all the pods that are running, which also shows you all of the resource usage of those pods, which is really neat. I could click on one of these pods if I wanted to. Here's my web app. I could see the usage of that container specifically. I can see the logs. I can click on logs, and you can see that in the terminal. This is an older version of the dashboard. The newer version of the dashboard actually has a button that you can click to exec into the container, which is really neat. You can look at the deployments. I mean, I don't have to walk you through this. You can poke around it yourself, but this is really nice for kind of a quick, oh, look at this. My cluster needs to scale. So this is another thing, like if you don't know what's wrong with your cluster, you can GUI, and they've got nice red text that you can tell you what's wrong. So there's that. And I think one of the main uses that I find from the console is that if I need to change the number of replicas, or if I need to change the container image really quick, and I don't want to bother remembering the commands on kubectl, I'll just go in here and you could say edit, and you could potentially just scroll down here and say, oh, I need 17 of these, and update it, right? And then it'll go. The other cool thing is that if you edited it and you changed anything, really, if you diff any of this stuff, it will spawn new containers. So if I wanted to change the environment variable, like say the port, I could change that. It'll spawn all new pods. If I wanted to change the version of the web app, I could do that, right? And then it'll spawn all new pods. It'll do that all for me.
Was that the same as what you were doing with config?
Yep, same thing. Okay, there's that.
Do you have any experience with Portworx?
Portworx?
Yeah, they have a persistent global namespace volume manager.
No, I have never heard of that. His question was, had I heard of Portworx?
Yeah, have you worked with them?
Have I worked with them? No, I have not. Sounds cool, though. Is it service meshy type stuff?
Yeah, I mean, they all come from like the top 5 to 10 storage providers.
Nice.
Founders, like senior engineers, and they basically built a storage container service which works with Kubernetes.
Oh, okay.
So
Got it. Cool.
it allows you to build data.
Write that down. Portworx? Portworx. All right. Thank you.
I have another question. Is the API version in the YAML files?
Yes.
How do you know which ones
Yes, great question. So his question was the API version at the top of all of those resources that we wrote, they weren't all V1. There was some beta. Here, I'll show you if you didn't catch it. So here at the top, the API version, so extensions V1, beta 1. This actually changes over time. This is actually based on the definition of the resource at the time. So say, for example, when cron jobs were a new thing, they were on alpha. And so the API version that you had to have at the top of your resource was an alpha API version. As those resources mature and they get GA'd, then that changes. And then, so what you really need to do to determine those, of course, they give you some overlap time when they phase that out. But what you really need to do is look in the docs. The Kubernetes docs are good, better than most, I would say. And if you go to the kube docs, it will tell you all of the current options on those resources. Yep.
So if I'm updating my web app, for example, to a new version, I'll just tell Elastic Beanstalk to go and do that.
Right.
Stand up a whole bunch of instances, stick them all on, wait for them to pass out checks.
Yep.
Is there some sort of mechanism to do like new version deployments?
Yes. Yes. So his question was about essentially rolling updates. If you push a new version of your code, will it automatically stand up new ones, drain off the old ones, and clean them up? The answer is yes. On the deployment, let's see. It's not defined on this one, but on the deployment resource, you can specify what method of update you want. The main one that we use is rolling update, which will do exactly what you're talking about. So it will take in properties, which are how many pods can I have unavailable at one time? How many pods can I spin up while I'm doing this process? So you can customize that based on your resources. But essentially, the process is that it will take that number, the number of new pods that you're allowed, spin it up, wait for it to be healthy, take another one down, spin up a new one. So you really have to have a 12-factor app because 2 versions are going to be running at the same time, hypothetically. You could potentially do blue-greens. I've seen blog entries where people do blue-greens. They usually have, so I've seen it a couple ways. I've seen different namespaces. So you deploy to one namespace, and then you flip the service on in that namespace, deploy to the other namespace, flip the one on that. That seems like a lot of process. You could potentially, I don't know, I'm trying to think of all the creative ways that you could do it. The answer is you can do it. Kubernetes will allow you to specify a ton of information about how you want your application to rolling update. I was talking to somebody about this before the workshop, in that they were having problems where containers were dying during a rolling update and customers were affected. When a container is killed, it is sent a SIG term. You need to process that SIG term properly. So you could potentially, actually, let me go back one step. We talked about health checks. On a pod, there's 2 types of health checks, liveness probe and a readiness probe. A readiness probe tells the service when to put a pod behind it. So if it fails the readiness check, the pod will not get traffic from the service. The liveness probe tells Kubernetes when to restart a pod. So if it fails a liveness probe, it will kill the pod and restart a new one, essentially. And so you really have to be careful about how you set those 2 to make sure that you're doing it properly. In the case of being really specific about zero downtime, you could fail the readiness probe on purpose so that no more traffic comes in from the service, handle that SIG term by gracefully shutting down whatever your app is, and that will drain off all of the work that's already happening, and then the container will go away. There's a timeout on that. So there's a setting that you need to be careful for, which is like termination grace period. If your application takes too long to shut down, it'll just get killed. So be careful about that as well. But yes, there's a lot of flexibility. You just have to do it right. And it took the community a long time to figure that out. There's a lot of discussion in the Kubernetes Slack about how to handle that properly, especially with Nginx. Yep. Mhm.
new endpoints,
Mhm.
that when we, like probably we are going to deploy a new version,
Mhm.
will the old version be like deleted, or like if we want to have multiple versions of that API, like we even delete it? What is the best practice that you suggest?
Right. So you cannot run multiple versions of the same deployment. Under the covers, a deployment creates an object called a replica set. A replica set is, this time I cooked this recipe, right? So if I change the deployment, it makes a new replica set. I cooked a new version of the recipe. If I change the deployment again, a new replica set. And the replica set is what controls the actual pods. So I didn't show you that because under the covers, it's not super important, but you can run multiple replica sets at once, is my point. They cannot be, I'm not sure that the deployment can control both of them at the same time. So the best practice in that case would be to have multiple deployments. Yep.
Like new image of that particular.
Right. Correct. Right. So I think probably what you're talking about is probably best served by having a different namespace. So deploy your new version with new endpoints to a different namespace. You can deploy a service to that namespace just as you would for your production, and you could test out those new endpoints. And then eventually you would roll those new endpoints out to production. That's how I would do it. How am I doing for time? I don't even know when I'm supposed to end, to be honest.
12 minutes.
Oh, excellent. I could answer questions all day. Would it help people if I tell you how to interact with the Kubernetes community? Kubernetes is highly successful because of its community. We can do what we do because of what we learn from the community. I am in the business of helping, and I all day sit in my Slack team and I help my customers with their kube problems. But there is a public Slack, Kubernetes Slack, that you can join. It has 1 million channels. It has a channel for each topic, and you can sit in those channels and you can learn. And you can ask questions, and you can have somebody from the community answer them. I often sit in those channels and help people as well. I would highly recommend that you do that. It's free, it's friendly, it's one of the best communities I belong to. And what's cool about that is that some of the maintainers, some of the creators, also sit in those channels. And so if you have a special use case, special problem, you can potentially create new features for Kubernetes. You could say, here's my issue. You either get help or they say, put in an issue. We're going to push this forward. And so you can have control over where Kubernetes is going, which is super rad. The other thing is that, of course, since it's open sourced, you can contribute, right? You can write code if you know Go. That will help other people with Kubernetes in the future. And so, I guess I'm like a pro bono Kubernetes evangelist. I highly recommend it. There are other ways that you can learn Kubernetes. The way that I got into Kubernetes was through a video called A Children's Illustrated Guide to Kubernetes. It is awesome. Actually, let me pull it up since we have time. I believe it was Deus that put it out. I probably don't want to play it, but it is a YouTube video and also a blog, which you could potentially go and watch. Funny story, I actually watched this with my 6-year-old niece, and she had no idea what was going on. But it's really cute, and it introduces you to some of the concepts that I talked about here. And it's a good launching pad. But what I wanted to point out about this is that there are so many companies, ours being one of them, Heptio, Deus, a bunch of companies who are basing all of their work, all of their product around Kubernetes because it's so enticing, it's so community-driven, it's so powerful, it's taking a lot of pain away, and we know that we can give back. And all of those companies will post blogs, will post workshops like this, will post YouTube tutorials, and you can learn from them. Kelsey Hightower, awesome guy. He does Kubernetes the hard way. He has many, many workshops on how to use Kubernetes on YouTube. You can potentially use those to get into advanced topics that I was unable to cover here. But, you know, there's unending resources for you to continue with this, and I would highly encourage you to seek them out. And, you know, if you troll our, I don't know if you troll it, but if you look through our GitHub organization, you'll see some of the tools that we use. I think I don't know if I already mentioned this to all of you, but I did mention this to a couple of people before the workshop, is that we did not want to write a platform. We did not want to write or rewrite any of the things that Kubernetes has given us. So we use f.k.a. to stand up our Kubernetes clusters. That's a Kubernetes project. We didn't modify it. We didn't rewrite it. We're using it, just like you can use it. And we have a framework that we call Pentagon, which is available on our GitHub, which is a framework around k-ops. We allow you to use it in a sensible way. It's kind of like an opinionated directory structure. It's going to make your life a lot easier. Check it out. It needs a lot of help. We need the community to help us make it better, give us input. We need more people to use it. You'll also see rocket scripts, which I mentioned a couple times, which is, again, a way to use kubectl. We didn't rewrite kubectl. We didn't say you need to learn a new DSL to use this. We're just going to give you some bash scripts, some niceties around the application lifecycle, right? And there's a million tools like this out there. I mentioned kubetail, kale. What's cool about the Kubernetes community is that everybody's willing to share all of these things that make their lives easier. And I would highly recommend that you check all of them out and then contribute back yourself. That's my spiel. I have 6 minutes left, and I've run out of content.
I'm curious about monitoring.
Yes.
Monitoring, well, how do you employ monitoring?
Fantastic question. His question was, how do you monitor this? How do you employ monitoring? Whew, that is a hard problem. Let me tell you. So there are some awesome, awesome services out there that will allow you to monitor containers and Kubernetes. The two that come to mind are Sysdig and Datadog. Datadog will give you a lot of container metrics. So they'll tell you how your container's running, how many versions of your container are running, how your ELB is doing, blah, blah, blah. It has a lot of reach outside of Kubernetes, but it also has, they have automated dashboards for Kubernetes. They can tie into both instance data and pod data, and they can even take in kube state metrics, which is a little bit extra. Sysdig is kind of an intriguing thing. They can allow you to do full system, full cluster captures. So if you're debugging a really complex problem, as you can imagine, with all of the layers that even we just in our demo app had, and you don't know where the problem is, Sysdig will allow you to take captures of what's happening on the cluster down to the, it's a kernel module, so it sits there. It knows all of the network traffic going to everything. It knows all of the system processes running, all the container processes running. And so they have a ton of introspection, which will allow you to debug well. Translating all of that into something meaningful is hard. I'm not going to lie. You could put a full-time engineer on this for weeks to get something useful out of it. So that's really the challenge. We have at ReactiveOps our own internal monitoring, which is based on Isinga, which needs help, but it does a couple things for us. It is deployed by a single container, which sits on a customer's cluster, and it reports back to our central monitoring the state of that cluster. So it will tell us things like critical pod health. It will tell us things like node readiness. It will tell us things like network performance, DNS outages, things like that. Those are all metrics that you can gain from the Kubernetes API. So all of that data is available to you. The Kubernetes API will tell you if there's node pressure, disk pressure, RAM pressure, if things are not scheduling properly, all kinds of stuff. And so it's really about extracting what you need. Again, a lot of work. This is one of those things that just the community is working on but hasn't decided on something yet. Like there's no de facto, right? Sysdig's trying really hard to become the de facto, but it's not yet. Does that answer your question? Yeah. Okay. Yep. Upgrades. Great question. So GKE, really easy. AWS, upgrades, not so easy. So he asked about upgrades. Okay, so you can do in-place upgrades. When a node comes up and it's provisioned, it potentially, most of the time, pulls its version of Kubernetes from node up in some cloud bucket somewhere and is configured as a certain Kubernetes version. If you wanted to modify the launch configuration of that instance, you could say, instead of version 1.9, pull version 1.7, right? You could do that. It's not that easy to do it manually. And doing in-place upgrades can give you a lot of problems. So if you do an in-place upgrade, you have to deal with the fact that if you have masters of a certain version controlling nodes of a certain version, you may have problems. So if you happen to upgrade the nodes first and not the masters, you could potentially run into problems. You're also talking about potential downtime based on your configuration, because when you update a node, you have to replace it and or restart it. And so you have to schedule that. For the most part, Kubernetes is very good at losing one node at a time. But then there you are sitting with an operator waiting for a node to restart and then restarting the next one. There are some rudimentary scripts to do rolling updates that are just essentially waits, but that takes forever as well. What we do at ReactiveOps is parallel cluster upgrades, which allows us a lot of things. What that means is we have a cluster of a certain version running with all the deployments pointed to it, and everything's golden, and the users are using it. And then we say, OK, we need 1.7 now. Stand up a new cluster. This is 1.7 cluster. We use infrastructure as code. And so with our framework, we can stand up an identical cluster of a different version. And then because we use automated deployments through CI/CD, we can point the deployments at that cluster, make sure all the apps are running on it, have the user QA it to make sure that 1.7 didn't add any new weirdnesses to it, everything's running fine, and then we just do a DNS switch. And then we tear down the old cluster. And we find that to be the most useful because we've definitely run into plenty of situations in which the switch to a new version did affect things. We got asked, those API versions in the resources change. Well, those change from version to version. So sometimes when you switch cluster versions, your deployments don't work all of a sudden. Also, the RBAC we've been talking about, the role-based access controls, that's newish. It was in beta in 1.5, and then 1.6 was kind of the time when everybody started using it. Like I mentioned before, if you don't have RBAC built into your resources and you turn it on, nothing works. And so doing that parallel upgrade kind of allowed us a chance to make sure that everything was going to be OK. And I would continue to recommend that because, as I mentioned before, it's like bleeding edge if you're talking about 1.8. And you don't know what's going to work and what's not going to work. And there have been plenty teeny tiny bugs that you would never, like 1.5. We had a thing where the Docker daemon would fall asleep after 30 days and never wake up. And so you wouldn't know that until as you were running it, right? So I think that it's good to be careful about those types of things. GKE does a lot under the covers to save you the hassle, and I think it does it well. We've never had a problem with GKE customers where they did a cluster upgrade and had a problem. So that's just colloquial, but yeah. Okay, I'm out of time. I would love to answer all of your questions, and if you didn't want to ask me in this situation, please do ask me at happy hour. Thank you for your time. Hopefully you're still excited about Kube or more excited about Kube, and you join the community and use it and are happy. And